are better for clay, stuff like that. This sits on the end of the drill flight there. And then in the middle, because as we're going down the column, you have this, what we call a drill ahead. You know, it's got a small little bit on here. So it's actually got this thinner drill rod inside as we're drilling. So there's actually two pieces that we connect together as we're going down. And this allows us, so at any time we can pull this out, and that's what we did last night. We pulled this inner part out and then waited overnight to see where the water came up to, so we knew where to put our well. Because the purpose of these wells is to get a representation of the water table. There's another well right over there that's set deeper. So we want to see if there's a variation between the deeper and the shallower systems, both in the pressure head, how high the water comes up inside the well, based on the force in that formation. And we can also get chemistry, so we can tell the origin of the water, age date the water. We can tell where the water came from through isotopes, both what elevation it fell on and the actual source.
That well here,
yeah, this is the pre-existing well. It was drilled by the Seabees. I don't remember the exact date, but it's an older well. It's a while. So it's obviously been here a while. So we're doing, in total, we plan to do 8 of these around the basin. In addition to that, we're going to do 2 mud rotary holes, which you're more than welcome to come and see that when we have that equipment out here. It's much bigger. The rig's, 40, 50 feet long. It's got a, 40-foot mast on it. And that uses, instead of just drilling and it coming up around the outside on this Archimedes screw here, it actually, you drill down and it's basically it's an open hole, and it's filled with a bentonite mud slurry. And that bentonite mud slurry keeps the hole open as we're drilling down. And then there's other equipment associated with that that actually cleans the mud out and gets all the sand and bad clays to fall out of the mud. So we keep recycling the mud over and over again in the same hole. And that mud does 2 things. It provides hydrostatic pressure to keep the hole from collapsing until we construct the wells inside and fill it with sand and grout, stuff like that. But it also creates what they call a wall cake. It's a thin, you want your wall cake to be about 2 to 3 millimeters thick, and it actually prevents water from coming in and the drilling fluid from going out. It's bentonite mud, so bentonite's a clay. It's a good kind of clay. It's formed by ultravolcanic ash. The largest deposits are in Montana and Wyoming and are the result of previous Yellowstone eruptions. So Yellowstone erupted, it fell, and got altered at the surface and creates a clay. And it's by far the best thing because the clay platelets and bentonite actually line up together and form that wall cake. So, clay is in plate-shaped morphology, but the bentonite clay does a really good job of linking those plates together. And we have other additives we add in the mud, a polymer, which just basically allows those clay platelets to line up better. We also we also adjust the pH of the water because we want a higher pH because the bentonite likes a higher pH, so we keep about a pH of 8. And then when we're developing the well, we monitor the pH to make sure we get all the mud out of the system.
What is the pH in the soil?
Here, I don't know because we haven't been using bentonite mud here, but we take the pH of the original hydrant water basically. So we have to get water, we need water basically. So you got to have a water source. Nice thing about this method is you don't have that bentonite mud infiltrating the system, so you don't have to get it back out of the system afterwards.
What depth did you hit water?
We hit water, it was about 68 feet. So we went 20 feet below that because based on the current rate of decline, we want the wells to last about 10 years minimum. If it doesn't come back up, we get a really nice El Nino and everything wipes them up a little bit, but it's hard to say, it's not instantaneous. It takes a water a little time to get down there.
Where are you putting?
70 to 90 feet, and then we'll take the sand 10 feet above so that the grout we use to seal off the well doesn't infiltrate the sand pack and get into the well and clog off the screen. So we put a buffer of sand above the perforations. This is only 10 feet. Normally we do 20, but this are shallow and we're using dry bentonite seal on this. So we use bentonite to drill the hole on mud rotary, and for all drilling basically they use bentonite to seal it off as well. Because it, just like it forms that wall cake and prevents water from coming in, prevents water from going down the well bore as well.
Is the rotary like moving reverse rotary? That like once we get that up from your to make sure it's not plugging up the formation?
Good question. Reverse rotary is typically used for production wells largely. It becomes more cumbersome in narrow diameter holes. You don't have the flow because it's basically it's a gravity feed system, right? Because normal mud rotary, pumping the mud down the center and it's coming up the outside, whereas reverse rotary is opposite. So it's coming down the outside and coming up the middle, and it's basically, so it works really good for production wells where you have really long screen intervals and a lot of sand to clean out, stuff like that. We have tried it in the past, but we haven't been. And we also like to drill smaller diameter holes because that gives us better geophysical logs. So